Okay, so today we are going to cover division. Not only are we going to do synthetic division, but we're also going to do long division. Now, most of the problems to solve them or to get answers for different types of problems, we'll use the synthetic division. So, first example we're going to look at is a division problem. Now, at the beginning of the school year, we actually did problems like this, where we factored this and then we looked for things to cancel. So in the cases where you can actually factor and cancel, that will work. But this is the only problem that we're going to do where we'll be able to factor it and cancel things. So at the beginning of the year, this is what we did. We factored the numerator. There was nothing to factor in the denominator. And then notice the x plus 1's canceled, and the answer was just x minus 2. Now we're going to learn how to actually divide this polynomial by this one. And we're going to use long division. Now, before I cover this, let me just review some third grade division with you, just so you understand the process. So, for example, if I ask you to divide 484 by 4, we remember that we're looking for how many times 4 goes into 4, or what are we going to multiply 4 by to make it 4. And 4 goes into 4 one time, and then you multiply 1 times 4, and then we subtract, and then bring down, and then repeat it again. 4 times what gives me 8? 4 times 2. So then you do 2 times 8 is 4, subtract, bring down. Check it again. Goes in once, remainder 0. Everybody good on that? Now, also, remember how to make an improper fraction into a mixed number? We figure out how many times 4 will go into 23. Goes in 5 times with a remainder of 3. And then you put the same denominator. Everybody good on that? Or even if you did it as a division problem, we're still doing the same process. We take the remainder, it goes to the top. The number we were dividing by is the denominator. Okay, so we're going to sort of use a combination of all of this information to divide our polynomials. So let's take a look at our first example. Now this is the same problem we just did by factoring, but now we're going to do it using long division. So I need to figure out what am I going to multiply x by to make it x squared. And that's going to be x, but I don't write it on top of the first term. I'm going to shift it over and write it on top of the second term. So now I need to distribute and multiply the x to the x and the x to the 1. And I'm going to write it underneath. Now remember, my next step is to subtract. So what I like to do is I just flip my signs to opposites. So now, x squared minus x squared is gone, and then negative x plus negative x is negative 2x. I now bring down the next term. I now have to figure out what am I going to multiply x by again to make it become negative 2x. And that's going to be negative 2. And now I distribute negative 2 to the x, negative 2 to the 1. So it gives me negative 2x minus 2. Flip all the signs to opposite. And now add your terms. And notice I get a remainder of 0. So the answer to this division problem is x minus 2. And if you remember, that's the same thing we got when we factored and canceled. Let's try another one. Yes?
So on the quiz or something like that, we can just do the top one then, right?
They won't be able to be factored. Nothing will end up canceling, so you're going to have to demonstrate the long division. But you know, if you're good at factoring and you can recognize that it would be something that would cancel, then absolutely. But if you're gonna be able to factor it and nothing cancels, then you can't do it. All right, let's try another example. This time I could factor this, but nothing cancels. So, for example, if I factor this, it's x minus 2 and x plus 1. But notice nothing canceled. So that doesn't help me divide anything. So that doesn't help. So I'm going to do the long division. So I again need to figure out what am I going to multiply x by to make it x squared. And again, I'm going to multiply it by x. The x needs to distribute to the x and to the 3. I need to flip the signs to opposite because I'm subtracting. It's like a keep, flip, change. This cancels, and then negative x plus negative 3 is negative 4x. Bring down, and again repeat the process. What are you going to multiply x by to make it negative 4x? And that would be negative 4. Distribute the negative 4, and you get negative 4x minus 12. Flip the signs, and you get 10. This is where that mixed number trick comes in. I take the remainder, and I put it over what I was dividing by. So your answer is written as x minus 4 plus, and it's your remainder, over what you were dividing by. Now, if there were a negative remainder, instead of a plus sign there, it would have been a minus sign in front of the 10, or a subtraction sign. Good so far? Anybody still need it? Let's try another one that's a little longer. Again, I can't factor that. It's not a quadratic equation. It's not a perfect cube. I can't even factor by grouping. So I'm going to divide. So here I got to figure out what am I going to multiply x by to make it 5x cubed. And that will be 5x squared. I'm going to distribute it to the x to the 2. And now I flip the signs to opposite. So make this negative, negative, and now I combine the terms. This cancels. This gives me negative 16x squared. I drop down my next term. And now I have to figure out what am I going to multiply x by to make it negative 16x squared. And that will be negative 16x. Again, distribute it. Negative 16x squared minus 32x. Flip the signs to opposite. And here I get 4x. Bring down the last term. What am I going to multiply 4 by? X by to make it 4x, and that will be 4. Distribute it. Flip the signs. And I get negative 10. So notice this time my remainder was negative. So I make it as it's a subtraction sign with the remainder over the divisor. One more example, and then we'll go on to synthetic. We're going to do the same 4 problems again, but using the other technique. But let's do this last one. Pretty good? Okay, notice this last one. It's jumping from an x to the 3rd power to a constant. Now, when I go to set up my problem, I can't have any gaps. I got to think of like it's a countdown. So I'm going to go from 3 to x squared to x to 1. So I'm going to add in some placeholders. So I'm going to start with my x cubed. I'm going to put in a 0x squared to hold the spot, then a 0x, and then finally my constant. I need to have like it's a countdown and represent from 3 to 2 to 1 to the constant inside the division box. So now that I've represented every single exponent here, starting with 3 and counting down, I'm going to divide that by x plus 1. And now I start the same process. What am I going to multiply x by to make it x cubed? And that will be x squared. So x squared distributes to the x and to the 1. Flip the signs. I get negative x squared. Bring down, even though it's a 0, I still bring it down. What am I going to multiply x by to make it negative x squared? And I'm going to multiply it by negative x. Distribute it. So negative x squared minus x. Flip the signs. This is gone. Bring down the last term. What am I going to multiply x by to make it x? That would be 1. And then x plus 1. Flip the signs. Remainder negative 2. So minus 2 over x plus 1. That is long division. Now we're going to go back and do all 4 problems again, but using a technique called synthetic division. When we use synthetic division, we do not use the variables. So I'm going to show you how we set it up. Anybody still need this example? Okay. All right. So I've got this L-shaped looking thing. Now, what I'm going to put inside here, or a row of, are all the coefficients of my top polynomial. So notice I have x squared minus x minus 2. This has a coefficient here of 1, and this has a negative 1. So I'm going to write 1, negative 1, and then negative 2. I'm taking all of the coefficients in front of my terms, including the constant. Now, outside of this L shape is going to be the number I'm dividing by. So I take the denominator, and I'm going to set it equal to 0. And the number I'm going to divide by is negative 1. Now, if it's an x plus 1 or an x minus something, it's generally you can think of it as just the opposite sign. But the way that you figure out what number you're dividing by is you solve for x. All right, so now here is the process, and I'll go slow. Step number 1 is to take this first coefficient, write it underneath that blue line. The next step is to take this negative 1, multiply it with 1. We will write the answer inside the box. And all the numbers that are inside the box in each column, I'm going to add them. So outside of the L, I multiply. Inside, I add. So now I'm going to multiply straight down. So negative 1 plus negative 1, and I get negative 2. I now go back, and I'm going to multiply negative 1 times negative 2, and I write the answer in the L shape. I now add the red negative 2 with the black positive 2, and I get 0. So now I have to put the variables back in. So I take these two numbers, the 1, the negative 2, and the 0. See how my first letter was an x squared? The next letter that I'm going to use is the one right next to it. So I'm going to put an x here, and then the next thing would be the constant. And this is the remainder. So my answer is x minus 2. This was the first problem that we worked out. Let me do it. I'll do another one. It'll get easier as you see another example. Everybody good? Everybody still need it? Okay, I'll wait. Good? Okay. Next one. Again, I'm going to pull all the coefficients. So I'm going to pull a 1, a -1 here, and then the -2. The number I'm dividing by, I take the denominator, set it equal to 0, because this is a factor, so I'm solving it. So I'm dividing by -3, and now I'll begin the process. Bring down the first number. Then you'll multiply, so -3 times +1 is -3. Then I'm going to add -1 plus -3, -4. I now multiply -3 times -4. That will give me +12. I now add -2 plus 12, and I get 10. The last number is always the remainder. And then again, I'm going to add back the letters. Notice I started, my first letter was an x squared. So behind the 1 I put x, behind the 4 is my constant. So my answer here is x minus 4 plus the remainder over the denominator, which is here. This was the answer to the second example we did. And now we'll do the third example, now with synthetic. Everybody good on example 2? Let's try 3. Again, we're pulling all of the coefficients. So I'm putting a 5, a -6, a -28, and a -2. I take the denominator, set it equal to 0, and the number I'm using is -2. I start the process by dropping down the first term. I'm now going to multiply -2 times 5, and I get -10. I add that column, and I get -16. I go back, I multiply, and get 32. I add and get 4. I multiply, and then I add. So now, notice this time I'm starting with an x to the third. So the letter I'm putting here now, I'm going to put an x squared, then an x, and then this is the constant and remainder. So it's 5x squared, you go down by 1, minus 16x plus 4 minus 10 over x plus 2. The next one is the one with the placeholders. I have to do exactly the same thing that I did for the long division. I got to put in some zeros. Everybody good? Let's try example 4. Again, let's fill in all our gaps. So x to the third, I need the countdown. I have a 0x squared. I don't have an x, and then I have my constant. So again, my coefficients, I'm going to pull a 1, a 0, and a -1. And what I'm dividing by, again, set the denominator equal to 0. I'm dividing by -1. Process is the same. Drop down, multiply, add it, multiply it, add it, multiply it, add it. And now I add the variables back in. Again, notice I started with an x squared, so when I go to put it back in my answer, this one's x squared, this one's x, constant, and then remainder. So x squared minus x plus 1, remainder 2 over x plus 1. Everybody good? Now we're going to learn something called the remainder theorem. And this is a really cool tool. We're using the same synthetic division, but when we get a remainder, it's actually going to be the value of our function. So, our remainder theorem states that if a polynomial, f of x, which is this, is divided by x minus k, so my x plus 2 is really x minus k. So we can see that my k value that went in here was really x minus negative 2. So we can see here that my k value is really negative 2. Everybody follow me on that? Or again, you can set this equal to 0 to figure out what k equaled, which is negative 2. So now, I'm going to do a synthetic division problem. And the answer that I get for the remainder is going to be the value of f of negative 2. So the process is the same. Take all the coefficients. We're going to fill them in. And we're dividing by negative 2. I'm going to bring down the 5. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add, multiply, and add. So now, instead of putting what the polynomial is of what I divided, I wanted to know what, when I plug in negative 2, what the answer to that problem is, and it's whatever the remainder is. This will help us if we were to ask to graph this. So if I needed a coordinate to graph, the ordered pair would be negative 2, negative 10. Now, before we learn this cool tool, if we wanted to find out what the value of 5x to the third minus 6x squared minus 28x minus 2, what the value of that is when x equals negative 2, it's kind of a lengthy process. I have to plug it in, cube it here, square it here, multiply it by negative 28. And once I do all of this and follow PEMDAS, the answer I'm going to get from this long problem is going to be negative 10. So if you ever want to figure out what a value of the function is without plugging it in, we can use synthetic division. So negative 2 to the third power is negative 8. This becomes negative 6 times 4. This times this is positive 56. I'll now multiply this, and then work left to right, adding these up. Negative 64, rewrite all of this. This will give me negative 8, negative 8 minus 2, and the same answer I got when I did the synthetic division. So if you want to find the value of a function by using the remainder theorem, all you have to do is take the coefficients, divide it, and that would give you the value of when f of negative 2, it equals negative 10. Let's try another one. Here it's asking us to find f of negative 3. So again, we write the negative 3 outside. So if they're already telling us what they want us to find, we don't flip any signs, we just put what's there. Put the coefficients. Now remember, here we have a gap. Notice there is no x to the third power. So I need to have my placeholder here, and I need to put a 0 x to the third. So a 0 here, then the 3, then the negative 4, then the -5. And now I just do my synthetic division problem, looking to find the remainder. So again, I bring down, I multiply, I add 0 plus 3, I multiply -3 times 3. I add 3 plus -9. I multiply -3 times -6. And I get 18. I add and get 14. And now I multiply -3 and 14 and get -42. I add those, and my answer is -47. So for f of -3, the answer is -47. Now, if you would have taken -3 and plugged it in for x, you would have gotten the same answer following PEMDAS. The next thing is still synthetic division, but we're going to use the synthetic division to test for zeros. So again, I'm going to plug all of this in. This time, in order to see if k equals 1 is a 0, I need to get a remainder of 0. So here, I'm going to take my 1, put it here, get all of my coefficients. So 1, -4, 9, -6. My goal here to test for zeros is I want a remainder of 0. So again, you just repeat the process. Drop down, multiply, add it up, multiply, add it up, multiply. Notice I got a remainder of 0, so you will say, yes, this is a factor. So if you get a remainder of 0, if it goes in evenly, then you will say k equals 1 works. As a factor, remember we can write it like this. Let's try another one. All we're doing is a synthetic division problem, trying to get a remainder of 0. Now, also notice on this one, see how this had an x to the 3rd power? This actually has 3 different x-intercepts. This is only one of them. So to find the other ones, I would either need to add x's to this and then try to either factor it or use quadratic formula to find the other 2 x-intercepts. And we're going to practice this some more. So the next example, this time they want me to test to see if -5 works. Now, remember when you're finding x-intercepts, you can factor this. So if you didn't want to do the synthetic division, I could actually just factor this and find out that it factors into x plus 5, x minus 1. And then when I solve these, x equals -5, x equals 1. So I can already see that, yes, it's going to work, but let me do the synthetic division and show you that I will also get a remainder of 0. So -5 goes out here. 1, a 4, and a -5, all the coefficients. Bring it down. Multiply. Multiply. I got a remainder of 0, so yes, it worked. It is a factor. And I already found the other one. See how it's got 2? So the 2 x-intercepts are -5 and 1. Let's try number 3. Same thing. Write the coefficients. So I'm going to write 1, 2, -1, and 6. I'm testing -3. Bring down, multiply, add, multiply, add, multiply, and again, it checked. So yes, this is also a 0. One more example where it doesn't work. And We'll put in all the coefficients. So 2, 9. This is a typo. This should be a 3. 2, 9, 16, and 12. And now I start the synthetic division. My goal is to get a remainder of 0. So 2, I bring it down, multiply, add, multiply, add, multiply, and add. Notice I did not get a remainder of 0, so no, this is not an x-intercept. A clue would have been that all of the signs in the polynomial were plus signs, so nothing's going to ever cancel away. So that would be a clue for you. But you do the division. If you don't get a remainder, if you get a remainder, then it's not a 0. If you get a remainder of 0, then you know that is an x-intercept. So your homework, I'm going to move the due date to Tuesday. Tonight's homework is to study for the quiz. Homework due Tuesday is 1 through 49, every other odd. So we will review this a little bit more on Monday, and then your homework will be this. And then we'll review it a little bit more on Tuesday. So quiz tomorrow.